We're going to do some problem solving with quadratic. So here's our quadratic, and what it's saying is the height of a function in reference to time. So I didn't write all the background, but this is like a little t-ball player, and he's playing t-ball, and this is the flight path of the ball. So we know the a value is negative. So if we're on our plane, probably does something like that. It goes up and then comes back down. It's quadratic. And it's in reference to time. So depending on time, the height of the ball varies. If we're 5 seconds later, how high is the ball? 2 seconds? Is it going up? Is it coming down? That's what we're kind of trying to find out. So the very first question says the height after 1 second. Okay, so in other words, they want to know when t is the value of 1. So we write, we'll write the equation. H at t is equal to negative 4.9 t squared minus, plus 6t plus 2. Okay, we need to find when t is the value of 1. So what we're doing is plugging in 1 for all of the t values. So here we have squared, that's the t value of 1, plus 6 times 1, I should write the brackets right, plus 2. So what we're doing is essentially just evaluating. 1 times 1 is just 1, and 1 times negative 4.9 is still negative 4.9. 1 times 6 is 6, and then plus 2. So this is going to give us a value, negative 4.9, 6, and 2. Let's do our little calculator here. Negative 4.9 plus 6 plus 2, we said, is equal to 3.3. Oh my gosh. 3.1. Okay, so there's the height of our thing. Second question, now that the dog stopped. When does the ball hit the ground? Okay, so we know this quadratic is facing down, and it does something like this. We need to figure out when it hits the ground. In standard form, they've given us the y-intercept. The c value is always the y-intercept. So we know the ball is being hit. Let's assume the height is in feet. So it's 2 feet above the ground when it's hit. Okay, so that's some good information. The last constant term tells us that. And most likely, it probably goes up and then goes down. It's possible the person hits it directly down and it's like a grounder. So we kind of got to figure out what the flight path of this ball is. In order to do that, we're looking for x-intercepts. This is not easily factorable. We can't use like our quick factor methods. We need to use the quadratic formula to solve this. Okay. So for the quadratic formula, we need to know the a value, the b value, and the c value. So this is our a, our b, and I've already stated that this is our c value. The quadratic formula states that the x-intercepts are equal to negative b, okay, plus or minus, you've seen this before, right, this quadratic formula? Okay, good. Plus or minus the square root of b value squared minus 4 times a times c, all divided by 2 times a. Very good, very good. Okay, so I'm going to draw out this information. We know a is negative 4.9, so a is equal to negative 4.9. B was 6, and c was 2. Great. With that info, we're going to plug this in, and again, we're just kind of going through solving. So negative, the b is a 6 value, plus or minus the square root of, we're looking at 6 squared, minus 4 times the a value is negative 4.9, and the c value was 2, and then everything's going to be divided by 2 times, and again the a value was negative 4.9. Okay, so from here on in, it's just working values out. This becomes negative 6 plus or minus the root of, so we got root. This is 36. This is a negative times a negative, which is a positive, times a positive. So I know whatever my absolute value is, we're going to be adding it. I'll figure out what that is. 4 times 4.9 times 2, so 4 times 4.9 times 2. So I didn't put the positives or negatives in here because I already evaluated whether it be a plus or minus. I just want the absolute value. So 39.2. So we're adding 39.2 to it. And then all of that is going to be divided by 2 times 4.9 will be 9.8, negative 9.8, I believe. Okay. We've got to figure out this little bracket here. So negative 6 plus or minus the square root of 39.2 plus 36, okay, 75.2, all divided by, I think it's 9.8. We'll check that after. Then we need the square root of this value. So my square root, let's see if I remember my square root values. Oh, luckily it's here. Square root of 75.2. Woo! Huge number. Let's just go with 8.67 approximately, okay? 8.67. So this is equal to negative 6 plus or minus approximately 8.67 over 9.8. Okay, so this is where this plus and minus becomes important. We essentially get two answers, so we're going to branch off here. We have x, well, I didn't write the x in here, but x is equal to negative 6 plus, actually the plus should be the only thing in red to differentiate itself here, plus 8.67 divide negative 9.8. And x is equal to negative 6 minus 8.67 divided by negative 9.8. So we're going to work out these wonderful values. This will become 2.67 over negative 9.8. We'll figure out what that is. This will become negative 14.67 over negative 9.8. Lagging a little here. We're going to get two values. This one is positive divided negative, so it will be negative. This is a negative divided by negative, so it will be positive. 2.67 divide 9.8, 0.27. So negative 0.27. And this one, 14.67, 9.8. Whoops, wrong way. 14.67 divide 9.8. 1.49 approximately. Positive 1.49. Okay, let's make sense of this. This tells me the ball hits the ground at negative 0.27 and positive 1.49. Okay, negative could mean the ball went backwards if we're measuring distance on the x-axis, but our x-axis wasn't measuring that. It was measuring time. So this is telling me that 2.27 seconds before time starts, so before we hit the ball hits the ground. So we've gone back in time. Essentially, this is illogical. This doesn't make sense. Draw a rough sketch of what it's trying to say. Remember we said that the y-intercept was at 2. It says that one of the x-intercepts is negative 0.27. So really the ball's not hit till this point, so this stuff is irrelevant. Then the ball probably goes up, and then it comes back down and hits at 1.49. So this is the one that's going to be relevant to us, our 1.49. Okay, so that's when the ball hits the ground. A lot of work for that with the quadratic formula and stuff. And let's double check. I've kind of graphed it out here. Negative 2.7, we rounded, and roughly 1.49. Those are the correct values. I'm going to zoom in a bit. Remember we said the ball was hit at 2. We didn't figure out the vertex, but there it is in case we needed to know it. Okay.